Hi, yeah, so as I was saying, right? So this is going to react with this, and it's going to create certain products. And the products is CO2 and H2O. Now, to know how many oxygens are going to react per benzene, we're going to have to look at the products then, because that's going to tell us. Well, it seems that we don't know what the relative amounts are still. It only works with one set of numbers. But yeah, it only works with one set of numbers because there's 6 carbons here, and it's going to react with oxygen to combine in certain ways. So you're going to expect those carbons to still be there. So I'm going to say, okay, maybe there's 6 CO2s, because I'm trying to keep the carbons the same. There's 6 carbons here, there's 6 carbons there. Okay, good. Now, there's 6 hydrogens here. There's also 6 hydrogens, so I'm like, okay, let me try getting, 6 hydrogens, okay? But let's see, we have, 15 oxygens in all. You see, a thing I kind of did was like, this only has C, so it's kind of easy just to draw 6 here. C is only on this molecule, so 6. H2, the only thing I can draw here is a 3. But these both have oxygen, so I'm not gonna try to balance it with this oxygen, because it's gonna be difficult. But anyways, yeah. So you have 15 here right now, okay? 15 oxygens. Through the sort of just trial and error sort of way. I tried to do it the simplest way possible. Like, as I said, 6 carbons, 6 carbons. 6 hydrogens, 6 hydrogens. It's easy because this is the only molecule with hydrogen, so it's easy to just put that there. But okay, so how much oxygen is there? Now we can kind of draw that now. We can see, there's only one, this matches, just the oxygens don't match now. And we see, let's see, 15, so this is just it's gonna have to be 7.5 over here. Now, you might be thinking, okay, so there's 7.5 oxygens, but you're thinking, well, you can't have 0.5 of an oxygen, can you? And typically, this was an easy kind of puzzle, I think. Or, it's pretty, simple. There's only a straightforward answer, only one answer. So you did that, you got the 7.5, but yeah, you can't have half of an atom. So you might be tempted to be like, okay, let's multiply everything by 2. And, you might get this. But I will tell you that this is actually a little bit, different of a question. A little tricky. And you kind of can here. This would actually be, the answer here would be 7.5. Because we're dealing with moles. If that makes sense. I'll restart. Okay. So, one benzene, 7.5 oxygens. I'm thinking, that a lot of time you would multiply everything by 2, because you can't have 0.5 of an oxygen. And, if you did that, you would get this. Just multiply everything by 2. But I say you don't have to do that here. Because even though you can't have 0.5 of an atom or a molecule, we're dealing with moles. So, it's not saying the combustion of one molecule of C6H6. Because obviously you can't do that. You need 7.5 O2s. But that's not what it is. It's not a molecule, it's a mole. So for every 1 mole, you're going to need about 7.5 moles. And you can have that because a mole is a larger number. It's 7.5 times 6.02 times 10 to the 23rd. So it's that many groups of the atom. So the 0.5 kind of doesn't really matter anymore. The decimals won't really matter anymore, essentially. I guess if you have like 0.33333, that might be a little weird, but even still, like, your answer is gonna be 0.334 or something like that. So that's why in this case you can actually, if that makes sense, like, it's asking for every mole of this. Well, you're gonna need about even here, you're gonna assume it doesn't even matter here, because you're gonna assume that you have 1 mole of C6H6. So if you plug in that to the equation, you have 1 mole C6H6 times, well, you're trying to get how many oxygens there are. So there's 15 O2 per 2 moles or per 2 C6H6. Like, you're still gonna get this. You're still gonna get 7.5. Either way, I mean, it's just a little weird, I just think this is like a weird sort of question, but it's also very straightforward. Like, no. So that's all for today.